Dear student, how are you? In previous class we had discussed about analytic function, the condition of a function to be analytic. We had also deduced the necessary and sufficient condition of a function fz to be analytic. In the meantime, I advised you to go through the CR equation in polar form and Laplace's equation in polar form as well. So you have to go through CR equation, Cauchy-Riemann equation in polar form and Laplacian equation in polar form as well. Today we will discuss about construction of an analytic function. How to construct an analytic function? There are several methods to find the construction of an analytic function. Among them, the best method or most useful method is Milne-Thomson method. Milne-Thomson method for construction of an analytic function is the most prominent one. So we will be using Milne-Thomson method today to construct an analytic function. Firstly, let us consider z. You know, z is the complex number. Z is considered as x plus iy, you know. Here z is a complex number. It denotes a point on Cartesian plane and the coordinate of that point is xy, you know, and the conjugate of z is x minus iy. So by adding z and its conjugate z bar, we get 2x, and from these we can find x is equal to z plus z bar divided by 2, which can be regarded as equation number 1. Similarly, by subtracting z and by subtracting z bar from z, we get z minus z bar divided by twice I. Here z is the complex number which is considered initially and z bar is its conjugate. So by adding z and z bar, we get x is equal to z plus z bar by 2. Similarly, by subtracting, we get z minus z bar is equal to z minus z bar divided by 2i, which is equation number 2. Here I is the unit of imaginary number. And thirdly, we need to consider an analytic function which is fz. Say w is an analytic function which is considered as fz. So fz is described as u plus iv. Here u is the function of xy and p is also the function of xy. So we can write down w is equal to fz is equal to uxy plus ivxy. Here uxy is the real part and vxy is the imaginary part. Now by substituting x and y from the relation 1 and 2, we get this u z plus z bar divided by 2 comma z minus z bar divided by twice I plus iv, etc., etc. and this is equation number 3. So we get 3 relation here, 1, 2 and 3. So now considering all these 3 relations as identity in 2 independent variables, if we consider z and z bar are 2 independent variables, then we can set z is equal to z bar. If we consider all these 3 relations as identity in 2 independent variables, z and z bar, then we can set z is equal to z bar. Then from equation number 1 we can find x is equal to z. If we replace z bar is equal to z, then x is equal to z plus z divided by 2, then x is equal to z. So this is our finding. And from equation number 2, similarly we get y is equal to 0. If we put z is equal to z bar here, then we can find this should be y. This should be y. So z minus z bar. If we put z is equal to z bar, then y becomes 0. Okay. And from the relation 3, we can substitute the value from 1 and 2. We get w is equal to fz is equal to u z0 plus ib z0 from x is equal to z and y is equal to 0. Now fz is equal to w is equal to uxy plus ibxy. You know, this is the as usual formation of an analytic function fz. So by taking first derivative of this function, we get f prime z, then dw by dz. See here, w is equal to u plus iv. If we differentiate this with respect to z, then we get dw divided by dz is equal to del u by del x dx by dz. Since u is a function of xy, you know, in case of function of several variable, we are to use partial derivative. So in this process we can continue dw by dz is equal to del u by del x dx by dz plus I del v by del x dx by dz. From this we can write del u by del x plus I del v by del x. Here we put dx by dz is equal to 1. Since x is equal to z, then dx by dz, if we differentiate this line with respect to z, then we find dx by dz is equal to 1. So we put dx by dz is equal to 1 here. We get f prime z is equal to, f prime z represents the first derivative of the complex function fz with respect to z. So which is f prime z is equal to del u by del x plus I del v by del x. This is equation number 4. From this, f prime z is equal to del u by del x, this remains the same, and in place of del v by del x we put minus del u by del y. We know according to the CR equation, del u by del y is equal to minus del v by del x. So we replace this here according to the Cauchy-Riemann equation. Now if we replace del u by del x by pi 1 xy, that means pi 1 z0. Here x is equal to z and y is equal to 0. From this condition we can replace this here. So del u by del x, if we replace del u by del x is equal to pi 1 xy is equal to pi 1 z0, and del u by del y is equal to pi 2 xy. Here pi 1 and pi 2 are two functions of xy, and then we can write this pi 2 z0. Here x is equal to z and y is equal to 0 from our findings from the above three relations 1, 2 and 3. So we get f prime z is equal to pi 1 z0 minus pi 2 z0. Now by integrating this line f prime z, if we integrate f prime z, then we get fz is equal to integration this with respect to z plus c. So this is equation number 5. So the construction of an analytic function is done. This is the construction of an analytic function when u is given and b is unknown. This gives the construction of fz. Fz is the analytic function when u is given and b is unknown. So this is one of our finding. Similarly, by following the same process, when b is given and u is unknown, then by replacing del u by del x, here comes the equation number 4. If we replace del u by del x by del v by del y according to the CR equation, in equation number 4 we get f prime z is equal to del u by del x in place. So we have to replace del v by del y in place of del u by del x. So f prime z is equal to del v by del y plus I del v by del x. This remains the same. So we get f prime z is equal to del v by del y plus I del v by del x when v is given and u is unknown. If we choose del v by del y is equal to psi 1 xy, so it becomes psi z0 since x is equal to z and y is equal to 0. Here psi 1 is the function of xy, and also by replacing del v by del x is equal to psi 2 xy, so it becomes psi 2 z0. Then we get f prime z is equal to psi 1 z0 plus I psi 2 z0. Now by integrating with respect to z, we get fz is equal to integration psi 1 z0 plus I psi 2 z0 dz plus c. So this is also our finding for construction of a complex number. So by using Milne's theorem or Milne-Thomson's method for the construction of an analytic function, we have to follow this process. So by using the construction of analytic function, we can easily solve a lot of problems about analytic function in this chapter. You have to practice the solved problem from this chapter, and you have to follow the traditional questions of National University, and as usually you have to go through all the definitions and all the basics on this chapter. Hopefully we will be discussing further about the analytic function, and then we will go to the complex integration segment. So till then, stay safe. Thank you.